So today we are going to show you how you can make volumes available to Kubernetes cluster, so that primarily you must stateless system. A stateless, for example, a simple web server is stateless. Even if you stop it and delete it, if you start it again, it is not session. So it is session impervious, in the sense previous sessions doesn't make any difference. But whereas if you are using a database is not session impervious, in the sense that it will be dependent whatever is happening to the previous session, not ephemeral. Okay. So we will show you how Kubernetes makes available persistent volume. To understand persistent volume, Kubernetes talks about 3 different kinds of persistent volumes. Okay, so that is, you can make available persistent volumes in 3 different formats. That is, we should say the first one is okay. One is read-write, that is read-write RWO, that is read-write once. This could be once. Then read-write many. Okay. Fourth one is read-only. So 3 different way you can make a Kubernetes persistent volume accessible to the container. Okay. Now, Kubernetes follows a strange type of, not strange, I should say, a different way of making persistent volume available. For example, if you create a persistent volume, okay, that persistent volume will be initially created as a PV, okay, and this persistent volume will be made available to your application.
Chanchal, sorry to interrupt. We don't see anything related to the volume or something. We are seeing some querying. Maybe I'm wrong.
Hello. 1 minute, please. Something has gone wrong.
Yes, yeah. Speaker is also there, and actually, I was even going through like the page which you are showing. It's different.
Okay.
So.
Okay. So let me check where things are going wrong. Okay. Now somebody, so that I can see the.
Yeah, we are able to hear you, Chanchal, no problem. But the page what you are sharing, I think it may not be related to persistent volume and stuff.
Right now the page I'm sharing, okay, it appears that screen sharing itself has something wrong. Okay. Stop share, then screen share, okay, and desktop share. We are not seeing this.
Oh yes, yes, we were not seeing this.
Now we were not seeing this actually. Yeah, okay. Sorry for stopping you, but it's good for everyone. Thank you.
Okay. Okay.
Yeah. So, could you just repeat, like
yeah,
you know,
yes,
context?
Yes.
Yeah,
definitely repeat it. So. Hello. Okay. Okay. So what I was talking about, Kubernetes understands creation of persistent volume. Okay, persistent volume could be made available in three different fashions. That is, read write once, read write many, and then finally read only. Okay, so this is known as access mode, persistent volume access mode. So if you search in Kubernetes documentation itself, PV access mode, that itself, okay. So persistent volume Kubernetes, so that will talk about the access modes, that is read write once, okay. The persistent volumes, and this has the various dynamic binding. I am not interested in that. I am primarily interested in access modes, okay. So what are the access modes that will be defined here? Okay. Where is the access mode? Precisely, I just want to show the access mode terms only. Access modes. Okay, here it is. The access modes, they can be read write once, okay, read only many, read write many, okay. So by the name itself, you can pretty much understand what they stand for, okay. Read write once means this particular kind of persistent volume could only be shared by only used by only one pod. So this could be written or used by only one pod or application, okay. Read only many, that is, it particular volume could be made available to multiple pods in a read only mode. And read write many, again, it explains the same thing. So this is what I was trying to talk, I was trying to convince you all about, or trying to convey you this concept with my diagram, okay. First of all, OpenShift provisions persistent volumes in two different fashions, okay. And this persistent volume is created by the administrator, okay. Now, a user should make a persistent volume claim, okay. Now, the persistent volume will be created out of a physical directory. The physical directory could be something, let's assume mnt/dar1, okay. This could be the physical directory, sorry. This is the physical directory, okay. And it is using this you have created a persistent volume named PV1. Now this PV1 is created out of a directory, okay. Now,
sir, your sound is very low.
Very low.
Hello.
Rebooting my system, something has gone wrong because I don't know what. So I'm just rebooting that. Just give me 1 minute. PVC, by default, Kubernetes makes a difference between what is a PV and what is a PVC. Okay, so let's understand what is the difference between the two. In particular, PV, you create a PV. This is a PV, and a PV then is made available to a PVC. PVC is known as persistent volume claim. Why there is a difference? You can create multiple PVs, okay, and each PV will have a different name, and each PV has to use this PV. A particular pod has to make a persistent volume claim. Okay, so usually persistent volumes are created out of, okay, that is directories on your hard disks. Each of those directories could be shared as a PV with a specific name. For example, this can have PV1, okay, and this could be PV2 and something like that. Now, PVs are created by the administrator. Okay, a normal user cannot create a PV because this has to do with system level access. And then PVCs are used by developers or actual users of Kubernetes infrastructure. User, administrator, and normal user, these things has not been introduced as such, but later on when it is introduced to, you will understand why there is an isolation between PV and PVC. Okay. So what really happens when a new pod comes up, that pod will do what? It will attach this to, a particular PVC, and this is the pod. The pod will attach this PVC. The moment it attaches this PVC is usually associated with a particular pod PV. For example, it will be associated with this one. So whatever PVC stands for to this physical volume. So once you have created your applications, everything that you write in using your PVC, it will be stored here. Now, even if all this gets destroyed, okay, but the data will be remaining there in the persistent volume. Okay, how do I create a persistent volume? Okay, at this point, I would like to introduce you to some documents of Red Hat documents. The reason is Red Hat has a rich Kubernetes. In particular, this documentation is made available for OpenShift only, but because Red Hat's OpenShift is also a Kubernetes distribution, so anything available there you can pretty much use for your Kubernetes learning also. In particular, there is one document. Now, how to find those documents? If you go type Red Hat documentation, okay, if you just type Red Hat documentation, this will lead you to this page. Of course, if you are using Chrome, something else, your result could be something different. The very first link that you get, click this, okay, and here at the top you will find OpenShift Container Platform. If you click this, it will open up the complete OpenShift documentation. Please keep this version 4, everything that relates to version 4. Click this 3.1, 3.x version, okay? So it will open up the links for the version 3 documentation. In this, each of these documentations, such these documents provides rich documentation about various aspects of Kubernetes, okay? In particular, there is one particular document that is developer guide, okay? That is, this developer guide is available in various different format. I am going to open it in single page HTML. If you feel like, you can download the PDF, okay? And it is a wonderful documentation. And in fact, you can copy paste code from these documents for various kinds of resource, whatever be the kind of resource. For example, if you want the data or complete YAML configuration, configuration for a particular PVC, you can type Control F persistent volume, okay, and press F3. Ultimately it will take you to a complete configuration of persistent volume, how to write a persistent volume, okay, using persistent volume, and what is a persistent volume, how it is attached to a persistent volume, claims, very detailed documentations, claims as imports. So I'll always suggest, if possible, always try to use this, okay, use this documentation at least. So in particular, here is a typical YAML format of a persistent volume claim. If you define a persistent volume claim, what is it? It's a kind of resource type, okay, and this particular resource type has a name associated. PV01 will be the name of the persistent volume. Its capacity 1 GB. Read write once. Access mode means it will be available to only one node. Thereafter, it is right now available in an NFS directory, okay, and the NFS server name is this, okay. So this particular volume, persistent volume, will be created with using an NFS shared directory, okay. So this is, once created, it would be made available to another system, whoever makes a claim. Now that guy must refer it with a name claim 1, okay, and that claim should come from a project named default. I am repeating it. Why it is important to understand the configuration? I am going so details. Sorry. What is happening? Okay, here it is. Oh, here it is. Where has it gone?
Persistent volume claim, isn't it? So
Now I'm talking about the persistent volume only. Okay, so that is important to understand what is persistent volume. Okay, so persistent volume and then space. So
27.5.
27.5.
Yes.
Okay, thank you. 27.5.
this document will it be available on the CKA exam or?
No, this is a Red Hat documentation. It is not available. Okay, so
For CKA exam, then we have to remember all this.
No, you don't have to, because CK also provides some skeleton of these things. I'll show you where it is. Okay, but this document itself goes into much detail. Okay, so and that's why it also allows you to understand in a what is a persistent volume and all that much more conceptually, allows us to make it even more clear. For example, here is the definition of a persistent volume. The persistent volume is a kind. What do you mean by a kind? In Kubernetes, everything is a resource or resource type. Okay, and the type of the resource is defined in front of kind. So whenever you API version, then you define a kind. Kind always defines a Kubernetes resource type. Thereafter, name of the resource, okay, and then you specify, spec stands for specification, and further details. Here you see it talks about 1 GB, 1 GI, and then read write once. Then this part defines how and what is a persistent volume. from where this particular persistent volume will come. So this particular volume is available in an NFS server, and the directory is particularly temp. So whenever the persistent volume will be created from the NFS server, this particular directory will be mounted. Okay, and out of that NFS storage, a new persistent volume will be created. Now, who can access this? To understand that, claim reference part is important. Okay, the claim reference, whoever comes and talks about a claim 1, I want a persistent volume, and my name, my private volume claim is claim 1, then this particular persistent volume will be made available. Okay, and claim 1 will be written where? It will be written in a PVC. So in PVC it is written as claim 1. Okay, so persistent volume claim and persistent volumes are two different set of concepts. Is it clear to you, or I should repeat it again? Here is a persistent
It would be great to summarize, quickly what is a persistent
okay
volume
okay
claim and
persistent volume is basically you create persistent volume out of a directory. Okay, and it is a particular kind of OpenShift resource. It cannot be directly used by an application or pod. An application or pod has to create a PVC. Okay, PVC refers as persistent volume claim, and a persistent volume claim should contain a reference about this persistent volume. Okay, that is, if this is a PVC for PV1, then its configuration should be something like this. The persistent volume claim should use the word claim 1. Okay, and volume name PV01. The volume name is what? This is the name of the persistent volume. Are you getting my point? This is a persistent volume claim, and it talks about a particular persistent volume name.
so to the inner pod, a volume named PV001 will be available from the NFS server. So NFS server, whatever called it.
So when the PVC it uses, it will automatically get attached to this PV1. Okay. So application does not know about the PV, what it is. It only has a reference to the PV. Okay. So normally administrators creates persistent volume and users use persistent volume using persistent volume claim. We are going to take a look at the practice so that we are going to create an NFS server. From the NFS server, we are going to share certain directories, and that directory will be used as a persistent volume creation, and subsequently the same volume will be used in a pod creation. Okay, that will make the concept even more clear to you. Is it okay?
Chanchal sir, just one before
Yes,
before
please.
before we proceed there further. If
Mhm.
we don't do this, like let's say for example, this persistent volume is a concept, right? But if you use normally the like the deployment which we do it, so where does that data store? Is it into
That
the
is just
node or
no,
somewhere?
that is just like
If we
Docker
do not use
containers.
this
Okay,
person,
okay,
okay,
because when you create in Kubernetes also, everything is Docker. When you create a container, okay, so that is basically a Docker like container. Okay, so everything that you have learnt in Docker is true for Kubernetes so far as containers are concerned. Okay, so just like that, in your Docker container, everything like that, in Kubernetes also, everything is created there only. Okay,
okay. So
and
like
it is
if we say that the replica sets were three, and it there was a worker node there, so it would have created there also the data everywhere.
yes.
Okay,
If the
yes.
node is created on the worker node, so actually everything is getting created there only. Okay, so
Uh,
but
Means
Sam,
wherever the replica is running, there it will create the resources, right? required.
Yes,
Sorry,
but
yeah,
why
data required.
now? Why we are sharing NFS? The reason being, NFS is somewhere lying outside your master. Are you getting my point? Usually, NFS server will be something in your network. So you can, your containers will be created in shared network storage. Okay, you need to understand this point. In order just container storage is provided in shared network storage, okay? So that it is accessible from any of the nodes. It should usually your master because there could be multiple masters, isn't it?
So you want to say that instead of sharing it on an individual pod, we are just using a single share location where every pod knows this is the location and this is how it.
No, the
Yeah.
first important concept that you try must understand is why we are creating PV using usually shared storage. For example, I'm talking about NFS. Why we are creating a PV in NFS? The reason being, the advantage is this PV, if you should not be created in the master, should be PV is created in the master, but so that network shared storage is accessible from all the nodes. Okay, it has nothing to do with the master.
My,
Are you
yeah, I
getting my point?
got your point. Like it is an external thing where all the data will be living there, so everyone can access
Yes.
that particular share
Not
storage.
only that, not only that. You deploy master in a normal today, your master systems will be deployed in CoreOS. In CoreOS, you cannot do anything. Okay,
Yes.
it is
So in case
immutable.
also one of the master goes
So
fail or bad, and where the data is live, so worker will be in unstable, right? Everywhere. So that's
not say no, NFS worker will not be access this shared file if it is in the master itself. Okay.
yeah. So single point of failure is like creating a persistent volume using NFS externally.
That will not be a single point of failure. NFS will have an advantage because even first of all, masters are not supposed to be doing anything other than serving for Kubernetes. That is the first concept. Second, now that all the masters usually gets created in CoreOS, so you cannot write anything on a master. That is the coming scenario of Kubernetes very shortly. Okay.
Chanchan sir, just as you mentioned, Core OS. So means Core OS is like what used for what? Kubernetes, as you said, like Core OS multiple times. So I'm just trying to understand.
Okay. Yes, I got your point. No, actually nobody understands. In fact, I should not be referring to CoreOS too much because CoreOS is an operating system created by Tectonic primarily for container orchestration. So that is an operating system exclusively designed and meant for container orchestration, or you can say for Kubernetes only. And that's why to be the best Kubernetes orchestrator. And Tectonic itself, they are the creator of ATCD and so many other things that you see in Kubernetes. Subsequently, CoreOS itself was taken over by Red Hat. Okay, and Red Hat now has completely taken over Fedora CoreOS. Now, what is this CoreOS? CoreOS is a particular operating system that is primarily designed for container orchestration. For example, creating masters, systems like vConfig can be configured on CoreOS. Okay, but in our classroom or in your Kubernetes, etc., cluster, many places, Kubernetes CoreOS is used by usually on a cloud environment, they will provide their own set of masters. Okay, so that they are going to provide you Ubuntu or something like that. Now, why we are using Ubuntu here? Primarily because in the cloud Ubuntu is free. That's why Ubuntu is so much popular. Anyway, so core OS is something that is usually not, but Red Hat's OpenShift completely now installs. It is also was using core OS earlier, but at some point of time there is. So if you want to know more about core OS, you will Kubernetes on core OS. Kubernetes on core OS, that will tell you how to do it. Okay. Kubernetes on core OS better bare metal, that will tell you installing Kubernetes on bare metal with Tectonic. Okay. Running Kubernetes on core OS. So coreos.com, this has already been taken over by Red Hat. You will not find anything much here now. Okay. But now it has become, they are being migrated to Red Hat. Okay. GitHub, how you can install. So what is CoreOS? CoreOS is an operating system designed for Kubernetes orchestration. That's all. Okay, and it is the most efficient operating system for orchestrating Kubernetes. Now Red Hat's OpenShift uses it. Many people are still using it. Okay, many Kubernetes distributions still using CoreOS.
So the
Anyway,
current, no, I'm sorry
for,
because it was referring here, but when we do this, when we are currently doing the exercise on the cloud OS that we are supposed to do. Okay.
In fact, that's why I said sorry.
No,
It
no,
should
that's
not.
fine. But thanks
I
for
should not.
additional learning. That is very much important for us.
Okay. No, in fact, yes, please.
Sir, this one, I've got a question here. Now you said that how about if a storage is a direct storage or a SAN, a LAN to be connected as a PV, from where you can claim a PVC. So
yes.
is that possible?
Yes.
Because type is NFS. Yes. Probably you can change it to something else.
Yes, you can sort of to change it to something else. In fact, Kubernetes supports NFS, GFS, other types of SAN. So many other types of SANs are getting included. Now, Kubernetes has entered into the next level of storage access, that is dynamically accessing storage using storage class plugins. Okay, that is very complex. So that's why I'm not referring to that in your Kubernetes CKA exam. Also, it will not refer to storage class. Improve your level of understanding of Kubernetes. You will get to see there is a whole, and you can attach additional parameters like storage class FC, AWS, EBS, so many other things. And each of those storage types are supported by Kubernetes. Just for the purpose of simplicity, right now we will in the classroom environment use NFS. Okay, but yes, you have raised a very pertinent question in the sense that whether it supports other type of file systems or not. Yes, definitely. It all supports, even including vSAN and all.
Right. And okay. The other question I would be asking here is, okay, you're saying NFS. So in the exam setup also it will be NFS only.
Yes, it would be. Yeah. It would be only NFS only. So you are expected to, and in the exam also everything more or less is used on Ubuntu. So that's why usually we try to deliver it on Ubuntu.
So sir, one more thing is there, that the PV we can is there. So PV1 we can use for multiple PVC.
Okay, so for multiple PVC, yes. When you, that's why I was talking of the various access mode. What is access mode? If a PV is defined as a read write many or read only many. Okay, I have already shown you about that particular page, read-write access of rebooted the system. I have already shown you RWM, that is read-write
Right.
once, RWO read-write once, then RWM read-write many, then R read only M, ROM, something like that. These are the three different. So a PV can be accessed by multiples. If it is read-write once, then only one PVC can access it. Okay.
And sir, in that YAML file you showed,
yes,
sorry, in that this PV claim some policy was there.
PV claim, PV claim policy. In the persistent volume, there is a policy, isn't it?
Yes.
This is PV claim policy. Okay. Thanks for raising this question. Okay. So this particular policy, this is a persistent volume. Suppose a pod has used a persistent volume, subsequently pod gets destroyed. Your Kubernetes cluster comes to know pod is destroyed and it has released the claim. Then what should I do? Should I keep the PV in this fashion? Retain means yes. In that case, what it will do, it will retain the existing status. The other option of retain is claim or destroy, something like that. So retain is even if the pod is destroyed, it will be retained. If other alternative option is
recycle.
Recycle, yes. I just thank you for adding this. I was just forgetting this policy. The other option is recycle. Okay, recycle means the moment the PV is released, the content will be destroyed, everything will be cleaned. Okay. Okay, so having said that, let us take a practical example of PV and PVC in a Kubernetes enterprise architecture. So first of all of you, let's log into this our Kubernetes cluster. Okay. So we are going to create in the Kubernetes cluster itself. That is, right now I am into that. Let's install a few package, because by default Red Hat Linux installs the NFS util package that is responsible, but by default Ubuntu does not install that. So now I don't have to do a Ubuntu apt-get update because it is already installed. All the updates are there. I should be doing an apt-get install. And the name of the package is I know that most of you are from Red Hat background only, not from Ubuntu and Debian background. So some of
course, yes.
Some of the packages will not be. So I am copying this command in our chat window so that you can type it. Okay. So this is the command I have typed: sudo apt-get install NFS kernel server. Okay. What happened?
We are unable to see the screen.
Yes, you'll be. I just clicked at all wrong places. Usually I find it very difficult to find the chat window. Okay.
Sir, one minute. For the documentation link, you selected 3.11, right?
Yes.
So what's the difference between 3.11 and 4? Is it different both or just no means?
I got your point. Yes. Why I have not used 3? First of all, this development documentation developer guide is no longer available in 4. Okay. Version 4.
The smart people.
That's not smart. That they're getting meaner. They don't want to share.
No, actually not meaner in a sense. It is available in a different fashion. And now we are not really They are not meaner, rather your instructor himself is not intelligent or aware enough. He is yet to be fully conversant with OpenShift's entire documentation package. Okay, I have started using OpenShift 4 version 4, and because the development package is not there in develop now, there is no developer's guide. It now gets distributed in application builds, images, notes, and operators. And I'm not really sure on which document I am going to get the same set of knowledge that I was getting earlier in the builder documentation developments. Okay, so develop has now become bifurcated into 4 different parts. Are you getting my point? It's not that they are not no longer making more documentation, rather much more additional documentation has come into existence, which is making our life very tough.
we,
Okay,
we
to
need to,
find.
yeah, we need to have a dedicated time for searching in
No,
Yes.
this is because everybody is following Microsoft. You see, Microsoft with the newer version,
Hmm.
they make it even more difficult, even more harder to sort out.
No, actually, one of the greatest problem with open source software is entire world is developing packages or improving packages for a particular system. And if it is popular, if something is popular like Ansible or Kubernetes, then the rate of development becomes, many more times. Okay, so every day something new is coming up, and all the time you are struggling or trying to you are finding it very difficult to keep abreast with the developments. So right now, what is my problem? My problem is I am not aware in which document all these documents are provided. I was available, I was aware of the older document, but the newer document I am yet to go through. Okay, so when I deliver a session on OpenShift version 4, that too DO288, which basically means developing applications for OpenShift. Okay, there I'm struggling now. Okay, because many of the things that I used to get so easily from this developer's guide, now I do not know where I'll get for OpenShift version 4. So, so that is really making our life very tough. You
no,
are
but
wanting,
the good thing, as you said, like, documentation, referring OpenShift documentation is important, because to understand such concepts like
yes,
Kubernetes.io doesn't have such much more detailed concepts and explanation, and that is why Red Hat comes, documentation really helps. Now I understand, like, why you are referring to OpenShift, because to understand the concepts it becomes very much easier. Yeah, we have to look it out. We need to have that extra time for that, doing those researches, but that eventually helps.
yes, that in fact, because OpenShift also, the underlying platform is Kubernetes. It is a Kubernetes engine that it is using. So all the resource type, unless it is a custom resource type or some resource definition, CRD, everything refers to something that is Kubernetes already is using. So that's why it is very important. You all the concepts that you get from Red Hat OpenShift also from this documentation, and these documentations again you can see that they are very beautifully divided. There is a CRO runtime guide. This such a beautiful CRO runtime guide you will not get anywhere. In fact, configuring CRIO with Kubernetes itself is a tough time. It is not that easy. But this document will make it clear to you, because all subsequent deployments of Kubernetes itself will be using CRIO or CRIO, not Docker. Okay, so to have a clear idea about Docker, here is the best documentation for CRIO. So things like that. So the things for which documentation is not available in OpenShift, you can get the documentation from here. Okay, okay. So let's get started with our task. So I have already installed, I have shared the command also. If any other commands that I have to share, I'm keeping the chat window open because we are doing something new. So right now we have used this command, sudo apt nfs kernel server. So NFL kernel server has been installed. Let us now mkdir, we will make a directory. Since I am working as Vagrant user, so okay, so we have created this directory. and we are going to change the permission of this directory to chmod 1, that is sticky mode set 777 read write executable for everybody. So anybody can write, but somebody cannot write. Sticky bit has been set, so somebody will not be able to write who has not created this particular file himself. Okay, now we are going to create a file using the command. You can write the file using vim also, so you can also or run the command bash. Okay, -c, which stands for execute a command, that is bash, sudo bash, because I'm going to write something here. Echo software. Okay, then redirect it to this particular file. This is a folder. Inside that we are going to create a file. Name of the file will be hello.txt. Okay, later on we are going to use this file. Okay, okay, so we have created a file hello text inside that opt-sfw, which, okay, now we are going to edit the etc exports file. So vim sudo, you have to do a sudo vim. I think you are all from Linux background. You are very much comfortable using these things. NFS etc exports is always the configuration file for O, and then /opt/ it was sfw, isn't it? We created it software, yes, sfw, and then you should be, anything after sfw should be shared, and star means it is shared with the world at large, anybody. Star stands for each and every system. RW sync, then no root squash. I presume all of you understand what is meant by no root squash. No root squash stands for anybody approaching this system as root or tries to write in this folder as root user. The default behavior of NFS server is to reduce him to the status of nobody user. Okay, so that is the default behavior of NFS server. If you put this line, that is no root squash, this basically means, this basically means that I am defining, even somebody writes it from the remote system as root, make sure you don't reduce his status as nobody. Okay, that's what it's all about. So if you want to know more detail, man mount and try to find out no root squash or man exports. That's all. Anyway, I'm saving this file. Okay, I hope I have typed everything. If somebody notices I am typing something wrong, please point it out, because I am typing all the time when I am speaking. Okay, so that really is an occupational hazard. Sometimes you commit great errors. Okay, now I am going to share this particular folder by using the command export fs, okay, -r, okay, recursive and all. Okay, so that will make sure that anything that is defined in your etc exports, you don't have to restart the NFS server as such. Everything is restored. So now we are going to test by mounting on your second node. Okay, how can I do that? I am going to log into my other node. So Control-Shift-T, Control-Shift+, okay, and I'm going to log into the other node is 151. Okay, I have logged in. Now I will try to, I mount on this system. This is a different system, worker node. From this worker node, I will try to mount it. Let me install a package into this, only then I'll be able to do that. Apt get install NFS common. Okay, so you install this package. By installing this package, I'm copying this command also in the chat window so that all of you can install it. Okay, so this is the command apt-get install nfs common. Okay, and once you have done it, you need to type this command show mount. The show mount command itself is installed by this package. Okay, okay. Show mount minus e usually is the parameter. Show mount minus e, then the remote system's name. Its host name was something like this, yes, K8S master. And name resolution is already taking place because I have already created an entry in etc es. So export list for, so it is visible from this. Now let us try to mount it. Okay, so we will try to mount it. Sudo mount, okay, this K8S master colon slash optsfw, okay, and then we are going to mount it in mnt. Okay, so we have mounted it. Now if we do an ls mnt, our hello text should be visible. Yes, it is visible. So we can see that we can easily mount it, and from network this particular folder is available. So I'm now going to unmount it. Umount /mnt. Okay, I cannot do that because I'm an ordinary user. Sudo umount. Okay, done. So now everybody is in sync.
Yes.
Yes, sir.
Yes.
Sir, for CentOS, for that this
Yes.
package will work nfs-common.
No, it is NFS utils.
Okay.
For Red Hat,
Since
you need to install the package NFS util. Okay. So, and in fact, with Red Hat, this show mount command, older variants of Red Hat, show mount command was working fine. With Red Hat 7 onwards, this show mount command is ill behaving. Okay. So you don't use the show mount command, directly try to mount it. Okay. If you are using CentOS. That will be my advice. Don't try show mount, because if the show mount command fails, don't tell me, sir, it is not working. Okay.
NFS version 4 onwards, it is not supported, sir.
Yes. So NFS version 4 itself is not supported. I'm not really too sure about that, because Ubuntu always
certain
uses,
floats are blocked. So and few other things are made after that. That command
yes,
is.
That RPC what is
yes.
blocked.
So no, the way Red Hat configures that package and default configuration, it is not NFS version 4, because I think the NFS version that is installed on Ubuntu is also NFS version 4, but they have not made the necessary changes. Okay. Yes, there is a configuration file you want to, which if you make the changes, okay, let's not go into that, all that. Okay, so we just wanted to make sure our NFS server is working fine, and it is working fine as such. So now we are going to write a PV, that is persistent volume, and using that persistent volume. So if you are not sure how to write that persistent volume, let us take this from here itself. Here is a persistent volume definition, isn't it? Usually if you copy it from here, let us copy it and paste it on any text editor. Usually I use all the time either of Sublime Text or Visual Studio Code. Let us use Sublime Studio, Control N, and paste it. So here it is pasted here. Now API version, persistent volume, metadata, let's assume the name as PV001. Okay, let it be that, or PV volume 1, something like this. PV and then volume 1. Okay, so something like more appropriate. And then it is capacity, storage 1 GB, access mode, read write once, we are all right. Okay, we are going to make it read write many. Okay, access modes read write many. Okay, and then persistent claim policy retained, and NFS path equals to our path is something like this. If I remember, it is OPT SFW, isn't it? So that's it. And the name of the server is KTS master. Okay, its name is KTS master.
Sir, just one thing, like
Yes.
how does the name resolution happen here? Like everywhere we are using IP address curl. So
Okay.
how?
No, actually here I have made sure I have populated my etc host file. That's all. Okay. So that's why it is working. So this, but in fact, to make sure that everywhere it should be working, at the beginning when you install, make sure you have created an etc host file. Okay, like this. That is sudo etc host file, and then make sure YYPP. For example, I have two worker nodes. The first one has an uh, name of IP of 151, and this one is worker 1. Okay, this is worker 1, and sorry, this. Okay, and the second one is worker 2. Okay, 2. Okay, and this one has an IP address 5252. Okay, so once you have created this one is not required. This line is superfluous. Okay, now save this file. Okay, now do an SCP. Okay, just SCP this etc host file on all your hosts. But you can do it even more easily by doing a cat etc hosts. Okay, cat etc hosts, sorry, and select this line from this terminal, log into the other terminal on the other node, and sudo vim etc hosts. Okay, sorry, it should be etc hosts. Okay, okay, the line is already here. So YYP, second one. So this is using the etc host file. You can actually make sure that name resolution is taking place. Okay, so that's it. I am using etc host file. So that is what is doing the name resolution. Okay.
But what about the pods? Like we are doing the curl for the pods. Those IP addresses, like how we will get resolve it?
Okay, okay.
Means
In fact, behind the scene, there is one more particular pod that is getting installed. Its name is Core DNS. Core DNS creates a set of namespace, that is names. Okay, the moment you create a new pod, it will already get associated with a particular name, with the name of the app, and that pod address and IP address, everything is resolved by core OS itself. No, not core OS, core DNS. Okay, if you are in your OpenShift, sorry again, you are in your Kubernetes system, if you try to find out kubectl, kubectl get po, okay, minus all, sorry, all dash namespaces, okay, it will tell you that there are certain pods, core DNS. These core DNS, they are responsible for resolving the pod to IP. Each of the pods automatically gets associated with a particular name, and that name is that internal name resolution within the cluster itself is configured by core DNS. I am not going to delve too deeper into the core DNS part. Since you raised the question, that's why I just wanted to answer it. Okay. So because that would be a bit more complex and may not be.
No, means my only the thing is like when we will access Nginx from outside, we'll not give the IP address, right? So we'll
Yes.
obviously give the host name. So I was just thinking like how does this
Okay,
resolution
okay, okay,
happen?
okay,
Yeah.
okay. Since you have raised the question, I will answer that question also. Okay, because even though it is not related to this part, in fact, this is the diagram we have created for service. Actually, when usually we access a particular pod service using service, isn't it? Okay,
Yes.
so this service will be then mapped to a particular name. Okay, it will be mapped to a host name or URL. Okay, so once you have created this, okay, you will create one more construct, and that construct is known as either it could be a root or egress type construct. Okay, so all external packet requests will come to this place. Okay, and once it arrives this, in fact this will take you to the service. Okay, and this part we are going to cover in network egress. We are yet to cover the egress resource about networking, so that's we are going to cover later on.
Sure,
So
sure. Not a problem, sir.
okay,
Thanks. Yeah, that's fine. We'll cover then later.
okay,
Yeah.
okay, fine.
Okay.
So anyway, so where I was just forgetting where I was. Okay, we are editing this file. So hopefully we have done everything right, read write menu, and the server is okay. Actually, went here to copy this name. K8s master is the name of this server. Okay, and do we need to? We don't have to do a claim reference as such. We are going to actually NFS path, etc. We are not referring to any claim reference, etc. Okay, so it appears everything is all right. NFS server and K8s master. Only one thing, we'll do it read only. Colon false. Okay, so here it is. This defines where from it would be mounted. Okay, persistent claim policy usually, and read write menu is the access mode, and rest of it you already understand. So we are going to copy this file content because I am using Linux. So if I just select means selection in Linux means copy. Now we are going to create a file named vim, and name of the file will let us name it as pv01 pv. Okay, not okay, p dot yaml. Okay, insert, then paste it. Middle mouse clicks in Linux. Okay, pastes in Linux. That's why I use a mouse. Okay, so anyway, once you have done it, save this file. Okay, now you create a PV using the command kubectl create -f, then the name of the file PV. Okay, so kubectl get, sorry, get PV. So it shows that PV named this has been created, and its access mode is RWX, that is read write many, reclaim policy retain, status available means as of now it is not claimed by anybody and nobody is using it. Okay, so wonderful. Now we are going to create a persistent volume claim. Okay, the name of the persistent volume claim will be something like this. You can copy from the other document that I have shown you, or else it is not much. You can write from here too. So from Red Hat documentation also there is a PV volume claim version is already available. So you can copy it from here itself. And okay, I can directly paste it here. Okay, we are going to create a new file named pvc YAML. So vim pvc.yaml. Okay, insert, then I'm going to paste it just like that. Only thing that I'm going to change is persistent volume claim is all right, that is metadata PVC. I am not going to make it as claim 1. It could be in inverted comma, it could be outside inverted comma, it don't make any difference. Okay, so in Red Hat documents it says it should be in inverted comma. So make sure whatever that you have access mode there, the same access mode you should be writing here. Okay, read write many and requests 200 MI. Okay, okay, so that's it. And we are not going to do a volume name, etc. Even if you do not put the volume name. Okay, escape :WQ. Okay, now create this PVC. How to create this PVC? Just the same way, Control R CRE create, and this create now should use the file name PVC volume 1, PVC volume, PVC YAML. Okay, so kubectl get PVC.
Is this namespace specific? We can create into namespace as well, right?
Yes.
Okay.
PVCs are namespace specific. PVs are not namespace. Okay, so they are infrastructure specific. Are you getting my point?
So PV is like default, like it is for everyone, and PVC has the access, so it should be a part of a namespace.
Okay, no, actually, every resource is created in a almost all every resource is created in a namespace. Okay, but PV is created outside those namespaces. That is, it is a administrative or infrastructure kind of resource. That's why it is not part of any particular resource pool. I mean, it is not part of any other
Namespaces or
namespace.
projects.
Yes,
Okay.
any other namespace.
Okay.
But
This is the exception.
PVCs are, yes, PVCs are namespace specific. Okay, so that's you need to. Thank you for raising this question, because I should also be pointing out all by myself, because I didn't point out. So you raised this question. Thanks for raising this question. So right now it shows bound. Let us take a look at the PV. What does it show? Yes, now PV also says that it is bound, and by default it is bound to PVC1. Okay, so usually it does not happen like this. That is, I make a claim and instantly I get it. It is not something like that. In fact, this documentation, why I expose this documentation actually exposes you to ideal kind of scenario. There should always be a claim reference part in your PV, so that you specify from where, which particular project or namespace it could be claimed, so that if somebody tries to claim it from a different project, it will not get attached. Then again, it must tell me a specific claim name. But in our PV, that is not true, isn't it? We have created our PV something like this. There is no claim reference. There is no project specific limitations. So that's why the moment you tried to create it, instantly it got attached, because there is no restriction as such. But real world, there should be restrictions. That means only if I inform you, then only as an user you can attach that particular persistent volume. Is it clear?
Yeah, if you have more than one PVCs happening on the same PV, the status will, and if the access was read write many, which is in our case is also, it's I think read write many. So Therefore, it's showing bound. So if somebody else, say he comes and also claims that a bit of the PV, so what will be the status there? Will it show something else or? Hello? Hello?
Hello, Chanchal, we lost you.
Hello?
Yeah.
If PVC was, because it's got read write many access type here, PVC, we've got a access type as read write many. So what happens if somebody else also comes within the project? He comes and accesses that. So now it is showing bound. Your status is showing bound. Somebody comes and he wants to, he wants to make a claim of say another 100 MB out of the 1 GB or whatever it is.
So it will also be bound from that all project.
Oh, so it'll show bound 1 and 2 and all that? No, it doesn't show.
Yes, we can make a claim and it will also be bound. So it will show you that it is bound to multiple persistent volumes.
And you said that, an intimation gets sent out if somebody else wants a claim from some other project, something else.
No, it is not an intimation. What I was trying to communicate is this is not the actual way of creating a persistent volume, because you always create a persistent volume with some sort of security. Okay, that security is defined in these lines. That is claim reference, claim name, and that namespace. This claim reference point makes your persistent volume only accessible from specific claims. That is, or from specific namespace. Are you getting my point? But we have not defined that in our persistent volume. So anybody can make a claim and attach that persistent volume.
So currently, like anyone can get an claim because it is in a default and we have not put any restrictions as such. Okay, but if we have put it into the namespace, only those namespace will be allowed to have that claim.
And also there is a claim name. This claim name should also be present there in your persistent volume claim. So this persistent volume claim should only come from only. So it will be made available to only one claim. Okay, the claim which will have this name, claim 1. Okay, so this is the way you create restrictions how one can access this particular persistent volume. If you don't want to put any restrictions, you remove all these references to claim and all that. Okay.
Sir, in the PVC file you mentioned 200 MB, but here is showing 1 GB in your output.
In my output, because actually you have made a request for 200 GB, but you have created the PV 1 GB only. So that's why it is showing you the output 1 GB. Okay.
So what was the 200 MB? Means is it
I have made a claim. I have made a claim of 200 GB, 200 MB. So, but it says the capacity is 1 GB right now. So you can. I am asking for only 200 MB, so it is all right. So you
is it not that the PVC should show 200 MB limit on the PV? It is fine. Yeah, I agree. On the PV it is 1 GB. That is why it's showing 1 GB. But from the PVC end,
this part is will only show you the capacity. As it said, what is the capacity? Okay, you would have been more happy to see here 200 MB in the capacity also. Okay?
Yes, yeah.
So no.
No, because generally
I got your point. Because there is a confusion, because I claim 200 and I'm getting it to 1 GB. What is this? Okay, it says no, sir, it is only capacity. Okay, So even if you claim for 200 GB, I can show the capacity is 1 GB. So you can access right now. But at some point of time, somebody else makes a claim to this. So he can get access for next up to 800
Okay,
MB.
so
Isn't it?
another
So
claim will say automatically the capacity value will
yeah,
change
yeah,
for 1
yeah.
GB to 800 MB,
Yes.
or okay, okay. So it
Yes.
on the
Okay.
fly dynamically it will change. Okay,
Yes.
okay,
Okay.
thanks. Yeah.
Okay. Okay. Thanks for raising the question. So we have done the PV part 2. Now we are going to create an NFS pod YAML. Okay. So this NFS pod YAML, I have already created a particular file for this. Let me make this file available to you because it's a long code. It would be very difficult for you to type. I'm going to make it available in there. Actually, on my
Paste,
paste bin.
paste
Okay.
bin.
Okay. So paste bin is the place where I'll be making available to this. Let me find out. Yes, I'm just making it available, and
Yes.
because it is available in my mobile. So
It's
We
all right.
thought we again lost you.
yes, no, you have not lost me. Rather, I lost you. Okay. XB. So I hope. Okay. So it is now available. Okay. Can you see it?
No, sir.
No, you haven't shifted your screen. I think it's still on that particular page.
Okay.
Your post bin tab on your browser has not come up yet.
Okay. Let me see. Paste. Okay, my paste bin page. I have already closed it.
Sorry,
Yes.
sorry, paste bin. Paste
Okay.
bin.
If
Sorry.
you actually in paste bin, my page name is comfortably numb. Okay. So you will find this comfortably numb is my page. Okay. So this is the file that I've just uploaded. Okay. So you can copy and paste this code. Okay, in a YAML
Could you
file.
just share that link, please? Could you
Okay.
share that
Yes,
link?
definitely. I'll do that.
Does this will be available later also, or it will go off this link?
This link, actually, usually whenever I create a paste bin link, only I make it available till the class goes on. Okay. So I delete everything.
Okay, so it's a just temporary
Yes,
link.
because
It's like your PVC. It comes and goes.
yes, it comes and goes. Okay, it's right, precisely. Very well said. Okay, it's in PVC. In fact, in Pastebin, you have a option of defining of how many days it will be there. Okay, there I usually in.
But could you just
putting,
do us favor, like if you are sending the links today, could you just send us YAML also, so we could practice it later, because anyway this link will be not available later, right?
so you can copy and paste it, save it. It's as simple as
Okay.
that.
Okay.
Okay. At some point of time, I have to write the hard code this. Okay, so many other things, and I just for the purpose of saving time during the class, and also to make sure others are in a position abreast, I usually make it available for the classroom only. Okay, and you can see it is in 23 hours. Next, after 23 hours, it will be 24 hours, it will be gone. Okay. So that's it. And you don't require it in any way. So since you can copy and paste it right now. Okay. So anyway, so let's get started. We need to create this file. Its name is nfs-pod.yaml. VIM. Am I audible?
Yes, sir.
Okay. If I don't get to hear anything from you for some time, I has become afraid. Raw. So Control A.
So just one thing, on the top of the line you mentioned API version. So is this always be version 1 or
No, it could be
okay.
version 1 beta, version 1.1. This defines the version of YAML syntax. This API version refers to the API version of Kubernetes as such. Okay. So each newer versions of API, there could be some additional syntax or resource types. Okay. It could be API.
This YAML could be sort of cheated to run through Ansible as well, isn't it?
Okay. No, actually, the Ansible's YAMLs make sense only to Ansible. It will not make sense to anybody else because similarly, these YAML, it is text formatting is YAML, but to make something out of it, only this is compliant to Kubernetes YAML formatting version. And these YAMLs only talks about the APIs, various API calls that you can make to the Kubernetes API server. Are you getting my point?
So,
All
so,
these.
so sir, like the API version is there V1. So is it about this particular YAML is compatible with the API server, KubeADM or sorry KPI Kubernetes API server?
Yes, Kubernetes API server, it can support multiple versions. It could support version 1, it may support may or may not support version 1 beta or version 1.1, but at particularly this particular format is compliant to version 1. That's all. Okay. When you say that API version,
Okay.
so this is compliant to API version 1. Okay. And in API version 1, these were the API calls that you can make. Okay. So basically, everything that you write in this YAML is basically you are making an API put, API call. Okay. So this will be translated to the API request in the Kubernetes server. Okay. I hope everything is right. We have done it. Okay. I'll save it. After saving it, we are going to create a pod out of it. Okay. So we all know how to create it. kubectl. Yes.
Sir, in this mount path will be opt only. OPT will be, or we need to change in this file.
As of now, I have not changed it anything. Okay. So let us be. It is the mount path of volume name, NFS volume, name is NFS volume, volume mounts, and then mount path is OPT. Okay. So we don't change anything. Let us see what is happening. NFS pod.yaml. Create. Okay. So minus
You
F
need to
is
mention hyphen expose
yes,
here.
yes. No, not
Okay, no,
hyphen.
not
Control
okay.
L. It is minus F. That is, you create everything out of a file. You need to put the minus F. If everything is all right, then what we should say, get to see kubectl get PO. kubectl get PO should show me it is creating a container, and this is a container type of Nginx, isn't it? Nginx, yes. Okay, so once it is up and running, container creating, running, okay, it is all right. let it come up, then only we can go. There
You
is
can use
also,
-W switch for
yes,
watch.
yes. Once it is created, we will do a describe just to see what has happened inside. That is, it has mounted that external volume or not. Why it is taking so much time?
You can also see an event, isn't it?
Also get events, yes. It has created the scaled up replica set to 1. So right now everything is fine. But why it is showing still container creating? It is not showing ready.
So is it deployed to all the replicas as well? So all replicas will have hold on the PVC.
No, there is only one, because there is only one replica. That means it will create only one pod. Okay. If it takes more time, then I'm not going to continue anymore. So because the troubleshooting, etc., will be done tomorrow, because I'll continue with these sessions tomorrow too. Okay.
Sir, how to log in into that particular pod? If is there, you use same kubectl-it, how do you log in into it?
Exec.
Same, sorry,
Yes.
kubectl exec.
Yeah.
Okay,
So whatever that you type in Docker, okay.
same thing. Okay.
kubectl exec -it, and then pod name, and then sh or something like that, whatever it is.
Okay, everything will be same except the Docker kubectl will come.
Yes.
So,
Okay, I'm leaving it like that. Tomorrow I'm going to start from here only, because I'm not really too sure what is going wrong. And if you try to do a troubleshooting here, it would take a lot of time.
Maybe
So
tomorrow morning when you come back, it would have done it by then.
tomorrow morning when I
When you come back, it'll be done, the container.
yeah, container will be done. Okay. So if it is done or not, I just usually I don't try to avoid time or waste time using a troubleshooting, that too, and that too in front of the participants. Okay. What really happens, you will receive lot many advices, usually which are unqualified. Okay. So that could anyway, I don't want to spoil your time also. So there could be something somewhere wrong in the file itself. I need to check it. So that we can do by anyway. This session is expected to continue after tomorrow, first session, entire first session. Okay.
fine.
So I'll take over from here only.
Okay.
So,
Chanchal sir, just
yes, please.
one thing. Like my organization has have a contract with the rancher. So just wanted, like, if you could just give, not now, anywhere, whenever you are free, just a little bit overview of how rancher would, just normal thing, like it's the same, because I see a lot of complexity in the rancher, and they are pushing us to do that thing. So it's difficult, very difficult.
It's very difficult. I can understand. And but what is that you want from me?
So like rancher, like they are creating the bootstrapping the cluster and
What
something.
they are creating is immaterial to me. I'm not interested. What you expect from me, that is.
No, yeah, because the thing is, like, they're having a lot of clusters, so they are having more than 50 clusters.
Okay.
So they wanted to us deploy these clusters in AWS environment.
Okay.
And so there are 7 master nodes, and
So okay, once
so
you have
it's very
understood.
difficult. Yeah.
No, it is difficult. Of course, it is a very difficult. Once you have acquired the mastery on Kubernetes, Rancher is basically a Kubernetes distribution, which rather makes your life easier because there are much more advanced tools available for Rancher, and using Rancher, it becomes much more easy.
Yeah.
But yes, real
But
world require.
not right now, but whenever later when you have
Even
some.
later also, I'm not giving you the assurance that later I'll be available. Okay.
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 So apart from tomorrow,
Yes.
how many classes do you expect to go?
So actually,